viewers, welcome to my YouTube channel Bright Mind EduPoint, and in this video I'll be covering the numericals on the topic of consolidation of soil. So let's get started. The first problem: a saturated soil has compression index Cc equals to 0.27. Its void ratio at stress of 125 kN per meter square is 2.04, and its permeability is 3.5 into 10 raised to minus 8 centimeter per second. So with this given data, I have to find out three things. The first of which is the change in the void ratio if stress is increased to 187.5 kN per meter square. Second, if the soil strata is 5 meter thick. And third is the time required for 50% consolidation to occur if drainage is one way. And the time factor is also provided as 0.196. So we'll start with the solution, and first we'll find out the change in the void ratio. The compression index can be defined as delta E upon delta sigma dash, where delta E is difference between E naught minus E, and delta sigma dash is log to the base 10 sigma dash upon sigma naught dash, where E naught is the initial void ratio, E is the final void ratio, sigma dash is the final pressure or the increased pressure, and sigma naught dash is the initial effective pressure. So the values are provided to us, and the only unknown in this equation is E, that is the final void ratio. So we'll substitute the values and find the value of E. So 0.27 is equals to 2.04 minus E upon log to the base 10. Sigma dash is given as 187.5 and sigma naught dash is given as 125. Substituting all these values, the value of final void ratio comes out to be 1.992. Now let us assume delta E be the change in the void ratio, which can be found out using the expression as E naught minus E. So E naught is 2.04 and E is found out to be as 1.992. So therefore the value of delta E, that is change in void ratio, comes out to be 0.0475. Moving on to the next part, that is the settlement, which is represented by delta H. So to find out the value of settlement, that is delta H, I'll be using the expression Cc into H upon 1 plus E naught into log to the base 10 sigma dash to the sigma naught dash. So this expression is used if the soil sample given is over consolidated, or you can say first over consolidated clay. So the values are given in the question, so I have to just substitute. So it will be 0.27 into 5 upon 1 plus 2.04 into log to the base 10 187.5, and sigma naught dash is 125. So the value of delta H comes out to be 0.078 meters, that is approximately 7.8 centimeter. Moving to the third part, in which I have to calculate the time required for 50% consolidation to occur. Now for finding out the time required, firstly I'll find out the coefficient of consolidation Cv, which is expressed as K upon Mv into gamma W, where K is the coefficient of permeability, Mv is the coefficient of volume change, and gamma W is the unit weight of water. Coefficient of volume change can also be expressed as change in the volume to the initial volume due to the change in the pressure. So the change in the pressure is represented by delta sigma dash, and the initial volume is represented by 1 plus E naught. So substituting the values, in place of K, I'll substitute 3.8 into 10 raised to minus 10 Okay, this is because it was given in centimeter per second. I have just converted it in meter per second. 1 plus 2.04 into delta sigma dash is 62.5. That is the difference between the increased pressure and the initial pressure, divided by 0.0475, that is change in the void ratio, into 10, that is the unit weight of water in kilonewton per meter cube. The unit weight of water is assumed to be 10. So therefore the coefficient of consolidation comes out to be 1.427 into 10 raised to minus 7 meter square per second. Also, the coefficient of consolidation is equal to Tv into T square upon T50 in this case, where D is the length of the drainage path. So time factor Tv is provided to us. The length of the drainage path can be computed since the condition is provided, and the value of coefficient of consolidation is already computed. So the unknown T50 can be calculated. So I can write T50 will be equal to Tv into T square upon Cv. So substituting the values in place of TV, I'll substitute 0.196. Since it is a single drainage, the length of the drainage path will be the height of the stratum only, that is 5 meters. So into 5 into 5 divided by 1.427 into 10 raised to minus 7. So the value for 50% consolidation comes out to be 3433,500 seconds, and in days it comes out to be 397.4 days, that is approximately equal to 398 days. Moving ahead to the second problem, a clay layer of 2 meter thickness is subjected to a loading of 0.5 kg per centimeter square 1 year after the loading. The average consolidation observed is 50%, and the clay layer has a double drainage available at the site. So we have to calculate the coefficient of consolidation and the settlement after 1 year if the coefficient of permeability is provided as 3 mm per year. So we'll see how we can find out the variables. So the total thickness of the clay stratum is provided to us as 2 meters. So therefore, due to the double drainage condition at the site, so the length of the drainage path, that is small d, it will be equal to 2 divided by 2, that is 1 meters. The total thickness of the clay strata or clay layer is given as 2 meters. So if I find out if I see the degree of consolidation, it is already provided to us as 50%, that is 0.5 in a time span of 1 year. The delta sigma dash value is also 0.5 kg per centimeter square because the pressure increment after 1 year of loading was recorded as 0.5. So we are assuming the initial pressure to be 0. So first we'll find out the coefficient of consolidation, CV. Now for degree of consolidation less than 0.6, that is 60%, time factor is calculated using the following expression, that is pi by 4 into u square, where u is to be put in the form of the fraction. So if I substitute the values accordingly, that is pi by 4 into 0.5 square, the time factor comes out to be 0.196. Also, the time factor is equal to coefficient of consolidation CV into T upon T square. T in this case will be T50, that is corresponding to 50% consolidation. So the value of time factor is known to us, the length of the drainage path is known to us, and also the time duration is known to us. So simply substituting the values, that is 0.196 equals to CV into 1 upon 1 square, the value of coefficient of consolidation comes out to be 0.196 meter square per year. Moving on to the next part, in which the coefficient of permeability is given as 3 mm per year. If I convert it in meter, it comes out to be 3 into 10 raised to minus 3 meter per year. In this case, I have to find out the settlement. So we know that K is equals to CV into MV into gamma W. Okay, so this expression was also used in the previous example, just the terms are rearranged here. So the coefficient of permeability is known, coefficient of consolidation is also calculated, unit weight of water is assumed as 10 kilonewton per meter cube. So the only unknown MV, that is coefficient of volume change, can be computed using this expression. So therefore 0.003 equals to 0.196 into MV, which is to be found out, into the value of the unit weight of water. It is written as 1000. We have assumed to be 1000 kg per meter cube. So therefore the coefficient of volume change is comes out to be 1.53 into 10 raised to minus 5 meter square per kg. But the value of delta H, that is settlement, can be computed using the following expression, which is coefficient of volume change into delta sigma dash into the thickness of the clay layer. So all these three values are being calculated and available with us. So we'll substitute it. So in place of MV, I'll substitute 1.53 into 10 raised to minus 5. Delta sigma dash is 49.05. The value was given in kg per centimeter square. If we convert it in kg per meter square, it comes out to be 49.05. And the thickness of clay layer is 2. Substituting that, we'll get the value of delta sigma as 0.153 meters. So therefore, I can say the total settlement is equals to 153 mm. And settlement after the time duration of 1 year, that will be the 50%, will be 50% of 153, that is 76.5 mm. So moving ahead to the third problem, a 2 meter thick layer of saturated clay lies in between two permeable layers. The clay has following properties: initial void ratio as 1.25, initial applied pressure as 2 kg per centimeter square, final pressure noted as 4 kg per centimeter square, and the coefficient of permeability as 2.8 into 10 raised to minus 7 centimeter per second. Also, liquid limit of soil is mentioned as 0.45, that is 45%. So using the given data, we have to find out the final void ratio of the clay soil, settlement of the proposed building, and time required for 50% consolidation. So we'll see how we can find out. So the value of compression index is not provided to us, but using the expression given by certain scientists, we can find out the approximate value of compression index. So Cc can be expressed as 0.007 WL, that is liquid limit minus 10. But this expression can only be used if the soil is remolded. But the question does not mention anything about remolded soil. It is mentioning about the soil at the site. So for that purpose, we'll use the expression Cc equals to 0.09 into WL minus 10. So for clay soils which are not remolded, in order to find out the compression index value, this expression can be used. So therefore, Cc will be equal to 0.009 into 45 minus 10. Liquid limit value is given as 45. Therefore, the value of compression index comes out to be 0.315. Now, once the compression index is known, we can find out the final void ratio. We know compression index Cc is equals to E naught minus E upon log to the base 10 sigma upon sigma naught dash. Here in case of sigma naught dash, sigma I is provided, and in case of sigma dash, sorry, sigma f is provided. So the other values are provided to us. So if we substitute it accordingly, we'll be getting the value of the final void ratio. So in place of initial void ratio, the value of 1.25 is substituted, Cc is 0.315, and the final pressure is 4 and the initial pressure is 2. So upon calculation, the final void ratio comes out to be 1.15. So the first part of the question is now completed. Moving on to the next part, in which the value of the settlement of the proposed structure is to be found out. So the settlement, which is represented by delta H, can be computed using the equation that is delta E upon 1 plus EI into H. Now, since the clay soil sample is normally consolidated, so for normally consolidated clay samples, the settlement can be computed using the expression as shown. So delta E will be equal to 1.25 minus 1.15 upon 1 plus 1.25 into thickness of clay layer, that is 2. So therefore, the settlement of the proposed structure comes out to be 0.088 meters, that is 8.8 centimeter. Now we'll find out the coefficient of volume change, which is expressed as AV upon 1 plus EI. Now AV is the coefficient of compressibility, which can be found out using the expression delta E upon delta sigma. So delta E is the change in the void ratio from the initial state to final state, that is 1.25 minus 1.15, and the value of the change in the pressure, that is delta sigma, will be 2 in this case. So 1 plus EI, if I substitute in place of EI as 1.25, the value of coefficient of volume change MV comes out to be 0.022 centimeter square per kg. Now we'll find the next part, that is the coefficient of consolidation, which can be expressed as K upon MV into gamma W. K, the value is provided to us as 2.8 into 10 raised to minus 7. MV has already been calculated as 0.022, and the value of unit weight of water in kg per centimeter cube comes out to be 10 raised to minus 3. So if I substitute all this value, the value for coefficient of consolidation comes out to be 0.0127 centimeter square per second. Now for 50% consolidation, we know that the value of CV will be equal to TV into D square upon T50. So therefore 50% consolidation time factor, we know it is 0.25 into pi into 0.5 into 0.5, that is 0.196. So therefore, substituting the value of time factor in the expression, we will be getting the value of time as 154.331 seconds, that is 42.87 hours. So that was the solution for the third question. Moving on to the next problem. A construction of a new building founded on a clay soil was completed in January 2010. In January 2014, the average consolidation settlement of the foundation in clay was recorded as 10 mm. The ultimate consolidation settlement in design was assumed as 40 mm. So considering the double drainage to occur at the clay soil site, we have to calculate the consolidation settlement that will occur in the year January 2019. So the first case will be finding out the time span. So the time T1, if I say, that is 2014 to 2010, the duration where the first consolidation was recorded, which is 4 years. and corresponding the settlement to the first time after the construction was observed as 10 mm. Let final settlement be represented by SF, which is 40 mm. Now we'll find out the degree of consolidation, which is the ratio of initial settlement to the final settlement into 100. So initial settlement for the first case is 10, final settlement observed in the design was 40. So substituting the value, the degree of consolidation for first case comes out to be 25%. Now we know the time factor corresponding to this degree of consolidation will be expressed as pi by 4 into u1 square. So pi by 4 into 0.25 into 0.25. Once we calculate it, the value for the time factor comes out to be 0.0491. This is corresponding to case 1 where the time required was 4 years, or we can say the time span after which the first settlement rating was recorded. Now, if the time square is 9 years, in which we are expecting the what will be the settlement in the year 2009. So after construction, that is accurately 9 years. So corresponding to this time duration, we have to find out the settlement, that is represented by S2. So we know time factor TV is equal to CV into T upon D square, where T is the drainage path, T is the time required, and CV is the coefficient of consolidation. Now since CV upon T square will be common for both the cases, or we can say both the time period, so we can conclude the time factor is directly proportional to time. So therefore I can express TV2 upon TV1 is equals to the ratio of T2 to T1. So TV2 is to be found out. TV1 value has already been found out as 0.0491. T2 is 9 years and T1 is 4 years. So the value for the time factor for second case comes out to be 0.11044. Now we know that time factor is less than 0.28, which is correspond the time factor value corresponding to 60%. So therefore I can say time factor is equals to pi by 4 into u2 square, that is 0.11044, and accordingly if I calculate it, the value of degree of consolidation corresponding to second case comes out to be 37.5%. And we know the degree of consolidation is the ratio of initial settlement to final settlement. Final settlement keep it as 40. The initial settlement assume it to be S2. Using the expression U2 is equals to S2 upon SF, the value of S2 can be computed. So U 37.5 equals to S2 upon 40 into 100. So the value for the second case comes out to be 14.99 mm, say 15 mm. So in the year January 2019, the average consolidation can be observed in the site as 15 mm corresponding to the data provided. Moving on to the next question. In a normally consolidated clay of liquid limit 65.65% and 5 meter thickness, the overburden pressure is increased from 250 kN per meter square by 120 kN per meter square. So with the help of this data, we have to estimate the settlement that take place. Assume that saturated water content and specific gravity of solids are 45% and 2.07 respectively. So we'll assume the initial, write down the data provided to us, the initial pressure, that is 250 kN per square, and the initial pressure or incremental pressure, that is delta P, equals to 120 kN per meter square. Firstly, we'll find out the value of compression index CC using the expression 0.009 into liquid limit minus 10. So Cc will be equal to 0.009 into 65.65 minus 10, which gives us the value of Cc as 0.5. Now, the initial depth or the total height represented by h naught is 5 meters. Let initial void ratio be represented by E naught. So therefore, I can say for completely saturated soil, void ratio E, that is initial void ratio, can be computed using the expression W into G. It is the formula is W into G upon S. For saturated soil, S value is 1. So the expression can be written as E naught is equals to W into G. Substituting the values, we'll be getting the value of initial void ratio as 1.215. Now using the expression of delta H equals to Cc into H upon 1 plus E naught into log to the base 10 delta sigma upon delta naught sigma naught dash, with the expression for the over consolidated clay, as the given clay is over consolidated. So substituting the value in play, we'll be getting the expression as Cc into H upon 1 plus E naught into log to the base 10. In place of sigma dash, it will be initial pressure plus the pressure increment, that is P naught plus delta P, and the initial pressure, that is sigma naught dash, is represented by Pu for this particular case. So substituting the values, in place of Cc I have substituted 0.5, which was calculated. Thickness of clay layer is 5 meters. 1 plus E naught is 1.215 into log to the base 10, 370 upon 250. So upon calculation and further simplification, delta H comes out to be 2.5 divided by 2.215 into log to the base 10, 1.48. So the final value of delta H comes out to be 0.1921 meters, that is 19.21 centimeters. So that was all from this video. If you have liked the video, hit on the like button, share it with your friends, and subscribe to our channel for more videos on the different topics of civil engineering. Thank you.